Flattening large pieces of wood by hand can be a real pain. Dust everywhere, endless setup time, and that constant battle with router heights. But what if I told you that we could make this process super easy and for a fraction of the cost of a $1,700 woodworker? We are building this massive router sled that's height adjustable, has a killer dust extraction, and only costs a quarter of the price of those fancy store-bought versions. No more shimming workpieces, no more dust storms. Ready to turn your wood flattening from a chore into a smooth and efficient process? Let's dive right in. First, let's talk about the big problem with flattening large pieces of timber. Picture this. You've got this beautiful slab, but it's warped in all directions. What do you do with this potato chip? Flattening large pieces of wood with a router can be a real pain in the neck. Set up the workspace, deal with a mountain of dust, and somehow make sure your cut is even across the whole piece. Now, you might be thinking, can't I just buy a fancy router sled and call it a day? Sure you can. But have you seen the prices of those things? The Woodpecker Slab flattening mill, for example, is a beast of a tool. It's got all the bells and whistles, but it will send you back a whopping 1,700 to 2,000 kangaroos. That's a lot of cash. At least for my wife, she would kill me, literally. So what about making your own slab? Lots of people try this route and I've seen some really solid attempts. But there's the thing, most DIY sleds are pretty basic, like the one I had. They get the job done, but they are not really in the same league as those expensive store-bought ones. They often have problems with alignment, and don't even get me started on this dust situation. Speaking of dust, let me tell you, it's a real nightmare with most setups. You're there trying to flatten your slabs, and before you know it, you're standing in a cloud of sawdust. It gets everywhere, in your mouth, your nose, your clothes, everywhere. It's like working in a snowstorm, except it's wood particles instead of snow, or epoxy if you're doing crazy stuff like me. Here's something a lot of people overlook when they're building their own sleds: height adjustment. It might not sound like a big deal, but trust me, it's crucial. Without good height adjustment, you're stuck shimming and fiddling every time you want to work on a different thickness. It's a real time waster, and if you are not careful, you could shim your workpiece unevenly, which in return either wastes a lot of material or you can't even get your workpiece flat at all. I learned this the hard way. A while back I built one of these basic DIY sleds myself, but man, I did feel the pain when I actually started using it. The dust was out of control, I couldn't get the height quite right, and don't even get me started on how long it took to set up the whole thing. It was frustrating to say the least. I really hated this process. But here's the good news. We've got a solution. A game-changing DIY sled that's going to solve all these problems. We are talking height adjustment from 1 millimeter to 20 centimeters. That's like 3/64 of an inch to 8 inches, I think. A killer dust extraction and a cutting capacity that will handle even your biggest slabs. And the best part, we are going to build it for the fraction of the cost of the fancy store-bought versions. Now, I know what you're thinking, it sounds too good to be true, but I promise, it's not. I'm going to walk through this step by step, and by the end, you will have all the knowledge you need to build your own super slab. No more dust storms, no more shimming, no more headaches. Alright, let's get down to business and talk about the secret ingredients for our super slab. You know how sometimes you want to build something awesome, but your wallet says not today? Well, that's exactly the challenge that we are tackling here. We are going to build a Ferrari of a sled on a Fiat budget. First up, we need the base for our router sled. Now, you might think, can't we just use a piece of plywood? Sure, but here's where it gets interesting. We are going to use a 12mm or half-inch thick acrylic sheet. Why? Because this stuff is tough as nails, but still easy to work with. You can drill it, cut it with woodworking tools, and it won't flex. Plus, it's see-through, which is pretty cool if you ask me. This 12-inch by 12-inch piece was only $30, so it won't break the bank either. Obviously, you could use a 3/4-inch plywood sheet or even foam ply if you don't want to go with the fancier route like I did. Next, we've got our linear guide rail. These are the real MVPs of our build. They are the same kind of rails used in CNC machines, which means they are precise and smooth. One set goes on the base and the other set connects the router platform. This setup gives us that sweet, smooth movement we need for perfect flattening. Now let's talk dust. If you've used a router before, you know it can turn your workshop into a winter wonderland of sawdust in no time. That's why we are adding a 4-inch dust extraction port. Why 4 inches? Because bigger is better when it comes to sucking up wood chips, and it matches the size of my dust extractor, which means we are optimizing our dust collection game here. For the height adjustment, we are using 4 pieces of extruded aluminum, 1 for each corner. We are threading these for bolts and drilling holes to connect them to our acrylic base. This setup lets us adjust the height from 1 mm up to 200 mm. Again, that's an 8-inch difference. That's a huge range that will let you work on pretty much any slab or tree for that matter that you can get your hands on. To bring it all together, we are using some 3mm aluminium L bracket to mount one set of the linear guide rail blocks. Then we are connecting these to the ends of the other guide rail set with 12mm plywood. It's like building a high-tech sandwich, but instead of bread, we're using precision engineered components. Yum. Now you might be wondering about the size of this beast. The whole sled measures 180 centimeters by 120 centimeters, but our actual cutting capacity is going to be 175 by 93 centimeters. That's 90 by 36 inches. It is humongous. You could easily flatten a table big enough for a family reunion on this thing. Here's the kicker. All these fancy components sound expensive, right? But when we add it all up, we are looking at a total cost of under 400 Australian dollars. Compare that to the woodpecker's version. It's about $170 for a smaller size and over $2,000 for a similar size. Now you can see why I'm so excited about this build. Alright guys, we've got our base plate sorted, but now it's the time for the real magic, the height adjustment system. This is where our sled goes from good to mind-blowing. We're talking about a setup that will let your router float up and down like it's defying gravity. So what's the secret sauce? We're using V-Slot 2020 extruded aluminum with 20 series steel T-nuts and M4 thumb lever bolts. Now I know that sounds like a mouthful, but trust me, this combo is gonna make your life so much easier. First, let's talk about threading these aluminum extrusions. Most people think it's a walk in the park, but they are in for a surprise. The real trick is using the right tab and keeping it lubricated so the tab doesn't snap. Ask me why I know that. WD-40 works great for the lubrication. Next, we have to mount the L brackets to our height adjustment system. Both L brackets have to be the exact same so the linear guide blocks line up perfectly with the rails. To achieve this, we will be drilling the holes for both brackets at the same time. The next tricky part is how to mark the drill locations for the linear guide rail blocks on the L brackets. Well, we are going to sacrifice a cheap bolt and essentially create some transfer screws. A super simple method to get a really precise solution. Once we have got our mounting holes, it's time to put everything together. This is where the magic happens. We are essentially creating a CNC system for our router. Each component needs to be aligned perfectly to prevent any unwanted friction that could mess up our cuts. So for now, I leave all my bolts and screws a little loose so everything can align itself once it's on the rails. So with this height adjustable system, we have a huge range. We could adjust our router to flatten a thin veneer or a huge slab without shimming anything. Pretty cool, right? With this system, you can dial in the exact height you need for your first cut and then fine adjust it with your router if you need to go deeper, a millimeter at a time. And let's not forget about stability. With our aluminium extrusion framework, but sturdy enough to handle the weight of your router without any flex. That means no more wavy surface or uneven cuts. Let's talk about the elephant in the room, dust collection. If you have ever used a router, you know how messy they are and how much sawdust is created in the process of routing anything. But we're here not to make a mess, we're here to solve problems. Remember when we first set up our sled base? We thought we had it all figured out with those stiff bristles on the side. Man, were we wrong. Those bristles were about as useful as a lollipop tasting like dog. They were so stiff they might as well have been made out of steel. It was catching the router and it made it basically impossible to move it smoothly over the workpiece. Well, here's the thing. What works on a CNC machine doesn't always work on a router sled. It's like trying to use a hammer to screw in a nail. Sure, you might get the job done, but it's not gonna be pretty. I knew I had to come up with a better solution. That's when I remembered something I'd seen online once. 3M door gap covers. The test was a bit of a fail. Anyway, those bristles are way too stiff, so they have so much rigidity that you really can't go back and forth with that route anymore. So the dust extraction is working really well. The rest is really smooth, but those bristles don't work. So we're gonna have to take them off. And I have a new product here, which is meant for doors. And this is more like a plastic. So that's a really thin plastic strip that is from 3M. That is way softer. You can see that here. And I can glue that all the way around. And then probably make some relief cuts so that you can move it back and forth. And then hope that will do the trick, because these bristles suck. 3M covers are flexible, like really flexible. They're designed to seal the gap under the door. This means they are soft enough to conform to all sorts of shapes. And that's exactly what we need for our router sled. We need something that can hug the contours of the workpiece and keep that pesky dust from escaping. Now it was the moment of truth. And you know what? It was finally working. The dust that used to fly everywhere was now getting sucked up by our collection system. Those flexible covers were doing their job, sealing the gaps and keeping the dust contained. I even improved this a little bit off camera by making relief cups every half inch or so, and then put a second layer on top of it. Obviously there is still a little bit of dust, but that can be expected. I would say it sucks up about 98% of all the dust, which is a huge success. So we are all set for the final assembly and our first big test piece. I've got to admit, I'm feeling a mixture of excitement and nervousness. It's like that moment right before you turn on a new power tool for the first time. You're pumped, but you're also a bit worried you might have messed up something. First things first, we need to do some final adjustments. I'm going through and tightening everything up, making sure all our bolts and screws are snug. This is super important because if anything is loose, it could mess up our cuts or even be dangerous. I started moving the sled back and forth and wow, it's smooth. The linear guide rails are doing their job perfectly. It's gliding like it's on ice. The moment the bit touches the wood, I can already see a difference. The dust collection is working like a charm. The 3M door gap covers are flexing and bending, creating a tight seal around the wood. It's catching almost all the dust way better than those stiff bristles before. But here's where it gets really cool. I started adjusting the height and it's like magic. With just one turn of those bolts, I can move the router up and down smoothly. No more shimming, no more headaches. I can go from barely touching the surface to way up high, all without breaking a sweat. Now for the ultimate test, a warped slab I actually cut myself with a chainsaw. I set it up on the sled, take a deep breath and start flattening. Guys, I'm for real. It's like watching years of frustration just disappear. The router is moving smoothly across the surface, taking off just the right amount of wood. No more guesswork, no more uneven spots. In just a few passes, this warped mess is starting to look like a usable piece of lumber. So now how is this version stacking up to the expensive store-bought versions? Well, our DIY version is matching them step for step. The cuts are clean, the dust collection is top notch, and the height adjustment is spot on. And we built this whole thing for about 387 kangaroos. It's not just about saving money though, it's about the satisfaction of building something with your own hands that works this well. Every time I use this sled, I'm going to remember the process of building it, figuring out solutions to problems and seeing it all come together. So well, we have taken a $1,763 problem and turned it into a $387 solution that works even better. I'm still amazed how smooth this sled runs and how much dust it actually captures. Now it's your turn. I've listed all the materials I used in the video description below. Your wallet will thank you and so will your lungs. Trust me, once you use this bad boy, you will wonder how you ever lived without it. Now check out this video next where I built the ultimate table saw upgrade that will change your cross-cutting game. As always, I appreciate you and I see you next time.